This is the last video for section 3.3, and this is just to cap things off nicely with a summary of the differentiation rules that we've gotten in this section. Now, all of the differentiation rules have been highlighted in previous pages of these notes, but this will get them all in one place. And I'm also going to write these rules in Newton's notation with the primes, whereas on the previous pages, they've been written in Leibniz notation with the d dx representing the derivative. So this will just give you another way to look at them and a way to have them all in one place. Remember, these are all ideas that you need to memorize, these rules and these properties here. So to kick it off, we had the derivative of x to the nth power. So here's x to the n, that's our function, and then the prime here is representing that we're taking the derivative. Okay, so for that, recall the derivative was n, bring down the exponent, okay, bring down that exponent as a coefficient, and then lower the power by 1, so nx to the n minus 1 power. And that is the power rule. Okay, now a consequence of that was the derivative of a constant. So a constant function, prime for the derivative there, derivative of any constant at all is always going to be 0. Okay, now for our derivative properties, we had a constant multiple of a function, so c times the function f. If you take the derivative of that, it's equivalent to, say, the constant times the derivative of the function, c times f prime. Then our other property or properties, kind of 2 in 1 here. This is the sum and difference properties. If you have f plus g, two functions added together, and you take the derivative, you could do the same thing by taking the derivative of each function and adding those together, f prime plus g prime. And then it works the exact same way for subtraction. If it's f minus g prime, same thing as f prime minus g prime. So there's your sum and difference property. And then we got 2 more big rules here. If you have the product of 2 functions, f times g, and you're taking the derivative of that, it's the first function times the derivative of the second plus the second function times the derivative of the first. So f g prime plus g f prime. Or you can also write those terms in the opposite order, just to make that very clear. Since this is addition in the middle, the order of those terms can be switched around. You can write this as g f prime plus f g prime. Okay, and some people prefer this second way of writing it because it relates a little closer to the quotient rule, which we'll have here in just a second. So this one is the product rule, product of 2 functions. Make sure you understand the difference also between this product rule here and the constant multiple property, because the constant multiple property is when you have strictly a constant times your function. Okay, so no variables at all can be involved in that C right there. Okay, if any variable is involved in that, like if there's an X in there, if your independent variable or variable that you're taking a derivative with respect to shows up, then it is a product rule situation, product of 2 different functions of your independent variable. So you cannot use this idea on 2 functions. You have to use that product rule, otherwise things don't work out correctly. Truth is, you can use the product rule on this constant multiple property. That actually turns out okay, but it's not necessary. You'll end up getting the same result, and it's faster to use the constant multiple property, but there are differences between these two things. So make sure you know when to use each one of those. All right. Now our last differentiation rule is going to be our quotient rule. This is for the quotient of two functions, f over g prime. And that we had the little, well, one way to memorize it was the low d high minus high d low type of thing. So if we do it that way, that's your low function g, derivative of the high function f. So g f prime minus high function f, derivative of the low function g. So f g prime over the low function squared, g squared. So g f prime minus f g prime all over g squared. And however you want to memorize that is up to you. I did that bottom times the derivative of the top thing, or there's, more other creative ways, I'm sure, out there. Now, just to reiterate, this rule right here is why sometimes people also like to write the product rule in this way, because then that second setup for the product rule matches up more closely with the numerator of the quotient rule. They both have gf prime as the first term and then fg prime as the second term. And then you just have to remember that it's a plus for product and a minus for quotient. So if that will help you, if that helps you to memorize it that way, then go for it. Because these are both legit ways of using these rules. So if that structure looks more appealing, then go with it. So yeah, there is your quotient rule. Okay. So that'll cap up all of our differentiation properties and rules that we've learned in 3.3. And we'll get some more rules in the coming sections, but these are the true basis to what we're going to be doing with these shortcuts and rules now. So make sure you get a good handle on these ones.